look at this discussion question, it says a planet is moving at a constant speed in a circular orbit around a star. I've drawn that picture here. In one complete orbit, what is the net amount of work done on the planet by the star's gravitational force? Is it positive, negative, or zero? And then what if the planet's orbit is an ellipse so that the speed is not constant? What happens then? Okay, so we're looking at these two situations. So the first thing to note about our circular orbit is that our velocity and our force are perpendicular. That means that the power, which is force times velocity, at any instant is going to be zero. Another way to think about that is the displacement is also perpendicular to the force at any instant in time, so the work is going to be zero. So because that force is perpendicular to that displacement, that's telling me the work is always equal to 0 joules at all the points around there. So on the trip around, the total work is going to be 0. So if work net equals 0, that also tells me then that the change in kinetic energy is also equal to 0. And a big reason for all of this is because gravity's distance doesn't change. So the potential energy stays constant, so we aren't transferring any of that potential energy into kinetic or out of kinetic. That's why it's staying the same. Now, in an elliptical orbit where it gets closer and then further away, that speed is changing. Think about how if I throw a ball up in the air and it comes back down, the further away from the planet is, the slower it's going, the closer it gets back to the planet, the faster it's moving, and that works the same way here. So we're going to be moving really slow out here, and we're going to be moving really fast in here. So at this point here is where our kinetic energy is a maximum, and out here a minimum. Just to kind of add some terminology for us here, this point that's closest uses the prefix para. So if this was, for instance, a planet going around a sun like here, this would be the perihelion, and then the point far away would be our ap prefix, so this would be the aphelion. I always remember it A away, aphelion, but however you want to remember it is fine by me. Now in this scenario though, as the object is moving away, gravity is doing negative work, and as the object comes back, gravity is doing positive work. But if I think about it, this is nice and symmetrical. So on the way out, it does negative work, and on the way back in, it does positive work. And so the net work between this point and coming back to that same point, or any point for that fact, the work net is also going to be 0, meaning the change in kinetic energy is also 0 for that full trip, meaning it's going to come back and be moving the same speed it was when it was last there. Also, to think about that potential energy aspect of it, the potential energy is the same here as it is when it gets back to that point. It doesn't matter what happened along the way, everything kind of cancels out for us there.